House lights on.
House lights on.
Palm tree on.
Palm tree on.
Television off.
Television off.
Lights off.
All lights off.
Hey guys, welcome to a different video for my channel. I've never done something like this before actually, so let's see how it goes. But today I'm going to be showing you guys how I created my voice activated lights / outlets for my room. So you guys saw them in the clip right before this one, and it's actually really cool. So as a proof of concept, even though it's daylight out, let me show you guys, you'll still be able to see it. I have lights going across my room on this little banister on the top, and I can say house lights on.
On.
House lights off.
House lights turned off.
And my little assistant, she will help me in turning them on and off. So this was actually a really fun project because I got to learn a whole bunch. It was made using electrical wires, Raspberry Pis, Python scripts, a whole bunch of different things. And I've never actually had experience in those fields before. So it was really fun for me to just get in and start working with this stuff. So if you guys want to, I'm going to give you all a showcase, first and foremost, a showcase of how everything works and how I created this. And then I'm also going to give y'all a kind of like a tutorial / I'm just going to give you all the resources to create this yourself if you guys really want to. So without further ado, let me go ahead and show you guys how it works first of all, and we'll get into it. Okay guys, well, at its most very basic form, step number 1 is to get my computer to recognize what I'm saying and understand effectively what I want it to do. So there's a lot of ways you can do this. The way that I use is called Voice Attack. It's an $8 program that's used for executing keybinds in mainly video games, but I find it works very well for my project as well. So you can see right here, Voice Attack is listening, and it's disregarding all of what I'm saying right now because they're not commands. But once it recognizes a command, such as house lights on,
Lights on.
it'll execute a Python script. Now that is step 2. Alright guys, well, step number 2 is once Voice Attack executes the Python script, here it is right here, the Python script will send a string of information to my Raspberry Pi. Now that's all that this simple script does, is send a string of information over the network to my Raspberry Pi, and that's all that step number 2 is. And it's very simple. It's through your local network. You don't have to go through any hassle. It's all local. Okay guys, now I have the Raspberry Pi open here on the remote desktop, and this is the more complicated server script for Python, but it's constantly listening for that packet of information or string of information sent by my Windows PC. So here it is listening. We'll get more into detail on this, but just understand that it's listening for that connection. And this is step number 3. It's on the Raspberry Pi. Okay guys, and now here is step number 4. Now, bear in mind, this is one of the first electrical projects I've ever done, so I kind of messed up a little bit, especially with the color coding of the wires. However, it works for now. Okay, so basically, here's the Raspberry Pi, and it's connected through the network. This is a Raspberry Pi 3, so if I wanted to, I could connect it via Wi-Fi, but it's connected via Ethernet right now, just for the heck of it, because I have 2 Ethernet cables running to my room. Okay, well, the Raspberry Pi is constantly listening for that string of information, and once it receives a specific string of information, it will activate or deactivate a switch right here on this relay board. And this switch will either allow or not allow power to go to these outlets. Now I can control up to 8 of these outlets. However, only 3 of them are powered right now because only 3 of them are connected to my TV, palm tree, and lights in my room. So that's basically it, guys. That is, like, in its most basic form how this setup works. And now I'll show you guys step by step exactly how everything works, and I'll point you guys in the direction and give you guys resources in the description, just giving you guys all the information you guys need if you want to do this project as well. Okay guys, so this is going to be step 1 in the the tutorial slash showcase for this project. Now, I went into a little bit, I touched on voice attack a little bit, but I'm going to go into a little bit more detail on voice attack now. So as I said before, guys, it's an $8 program, but it can be used for so much on your Windows PC. Just being able to control things with your voice is very, very helpful. I haven't used it for this project. Like, I didn't buy it specifically for this project. I bought it actually to play video games and play video games such as Star Citizen and Elite Dangerous. They're space simulators where they require like a lot of key presses at one time, and I can execute those key presses with the sound of my voice. So obviously you could see kind of the reasoning behind my use and purchase right there. But it's also just very, very awesome and just, you know, working around your desktop, and it works perfect for this application as well. Okay, so basically, if you guys have seen right here, voice attack is listening to the levels of my voice and trying to guess at what I'm saying. It's guessing, oh, what is he saying? I don't know. It's only going to recognize the commands that I've manually set for it. Okay, so the commands are here. This is just one of the profiles I have. So if I say house lights on, so this is one of the commands, let's just go into it. If I say any variation of house light on, and Risk will recognize it. Risk is the voice assistant I have, the name that I've given her. If I say any variation of house light on, whatever that I've manually configured in here, Risk will run an application that is this application right here. This is the client script that we're going to get to in step 2. Risk will run this because she has the power to run this, and then she will give me verbal confirmation.
House lights on.
She'll give me verbal confirmation that the program was run, and basically that's all the Windows PC does. It will just that in itself will send the string over to the Raspberry Pi. So that's how it's done in voice attack, guys. If you want to learn how to use voice attack, how to configure it, I might make a video about that. I might not. It just depends. But there's a lot of tutorials out there on learning how to configure voice attack. However, bear in mind a lot of them are going to be for video games. They're not going to be for this application in general. So that's that, guys. There's kind of a problem because it's kind of a hassle to have a Windows PC in order to use voice attack because it's Windows only, and have a separate PC to execute these commands on the Raspberry Pi. So maybe one day, because I've heard of people trying to configure Windows 10 for the Raspberry Pi. If I can boot Windows that like bootlegged a Windows 10 version onto the Raspberry Pi and it's able to run voice attack, then I won't have to have this Windows PC separate at all. I will make a follow-up video based on that and just have a microphone connected directly to the Raspberry Pi. Okay, that was a lot of words, but that was basically step 1, guys. It's just using voice attack and just how voice attack is able to execute commands on my Windows PC and send that string of information over to the Raspberry Pi. Okay, guys, so that was step 1. Now we're going to go on to step 2, which is the actual client script right here. Alright, guys, so now we're going on to step 2, which requires Python. Okay, so I honestly have never programmed in Python before this project, so it was kind of like this project was kind of like an introductory for me to learn how to use Python, especially with the Raspberry Pi, because the Raspberry Pi is really dependent on Python for just entering into like the GPIO pins and controlling a lot of things. So I have the Python webpage open here for this one specifically, for this project specifically. I think I'm using Python 3.4.4. And that'll be apparent once you start looking at some of the code here. So if you guys don't have that version, you might have to modify some of the code that I've written in order to fit your Python version. However, here is step 2, and I've opened up one of the files that Risk will run using voice attack. So for each command I give her, say I say house light on, she will run the house light on script. If I say house light off, she'll run the house light off. And the only difference between these two is the string that is sent over the network. It's just a different string for each file, but it's the exact same file otherwise. Okay? And the reason it's like that is because voice attack can run files, but it cannot run functions within the file. Okay? So that's why I had to have a separate file per command. Okay, but now I kind of want to explain some of this, some of the script, just so you guys don't get confused, and if y'all need a troubleshoot, it'll help you out. And plus, this is one of the first projects I've ever done in Python, so obviously it's not going to be the best, and it's going to be pretty sloppy. So it's better if I just try to explain to you guys rather than y'all figure it out by yourselves. Okay, so I'm going to be honest, I cobbled together most of this from things that I've read online and tutorials that I was learning, and a lot of it wasn't my own, code. However, I did write it all, and it's got like I've edited it in order to, for it to fit my purposes. However, a lot of it's just basically like generic sockets and stuff. Okay, so like up here, you have to import the socket and system module, for Python. And then down here, you're gonna it's gonna try and open a TCP socket for this host import. This host specifically is the static IP I've given to my Raspberry Pi. So in the description, guys, I'm gonna have a link to a GitHub page where you could download all of this stuff. I'm gonna give you guys one of my scripts like this, and also one of the templates. Okay, so if I open up this one, and oh geez, I have a lot of these things open. Okay, so here's the one that I run, and then here's the client script that I run. Okay, this is the house light on, and here I have one that I've modified for you guys just so it's easier for you to input your own commands. Okay, so here you see I have the host, which is the static IP I've given to my Raspberry Pi. So if you haven't, you're gonna want to give your Raspberry Pi a static IP on your local network, and right here in the template, I just put IP of server. So this is the IP of your Raspberry Pi, and it's going to connect via port 12344 or 12345. I had some problems doing just a single port, so I just put both of them. It's perfectly fine. It works perfectly. Okay. So then it's going to try and connect to the host. If it can't connect to the host, it'll give you an error. And then basically it'll print the IP of the remote server of the IP of the Raspberry Pi, which should be this one. Okay, so it'll print it, and then it'll connect to it, and then it'll print. It'll say like, oh, it's connected, whatever. It's a lot of redundant stuff, but a lot of these prints are in here just so I know that things are happening within the scripts. Okay, now here's the message. All right, so this is the string. This is really important, guys. So here's the string you're going to be sending from the Windows PC using VoiceAttack to the Raspberry Pi. This one says house light on. You have to spell it exactly the way it is, and you're gonna encode it. And you have to spell it exactly the way this is. This could be basically whatever you guys want. The only reason I put house light on is because this script itself corresponds to the house light on command on the Raspberry Pi, or function on the Raspberry Pi. Okay, so here I just have appliance on in the templates that I'm going to give you guys. I just use the word appliance because you're going to be powering appliance with this. So say you have a television you want to turn on. You're going to go over here and put television on, and that's the string of information you're going to be sending to your Raspberry Pi. It says television on. This is all for organizational purposes, okay? But otherwise, it's the appliance. Okay, and then you're just going to send, you're going to send it to all the computers on the network. You're going to send your message, because this is the message, variable message. And if it doesn't send, it'll give you a send failed. So there's a lot of prints in here, just so you can troubleshoot if something went wrong. And then it'll say print message sent successfully, and then it will receive a reply from the Raspberry Pi server that you can set up. I have it just to say that reply received, so that I know that the connection was successful both ways. And then it'll print the reply, and then it will close using the the sys module thing. And then that's basically it. It's a super simple script. And if I run it for you guys right here, you guys see it says print socket created. It created the TCP socket right here, and then it'll connect to the IP address 192.168.1 or 1.244. Connects to it right there. It'll say socket connected. There's a lot of redundant IP addresses, I know that, okay? And then finally, it'll say message was sent successfully. That's after the message was sent. And then we reply from server Pi received. This is the reply from the Raspberry Pi, so that you know that the connection was successful both ways. Okay? And it has to be successful both ways, or else TCP won't work. Okay, so that is step 2, guys. Just a very, very quick overview of this. Kind of quick. Just understand, guys, the only thing I changed from here, so if you guys, say you wanted to set this up yourself, okay, you have your Windows PC, you have voice attack, you have everything set up, right in here, this is the only thing you're going to do. You're going to download the template, okay? In here, you're going to put like 192.168.1.244, okay? It's just some static IP that you give your Raspberry Pi. It could be whatever. It could be like 233.214, whatever you want, okay? It just has to be a static IP address for your local network. All right. Then, what you're also going to do, you can come down here, and you're going to give the message you want to send, okay? So remember, you're going to have to create a new file for this, for every single appliance you're going to want to turn on or off. So say this is appliance on, this is like a lamp or something. It's going to be like lamp on, okay? Now, if you're creating if you want to turn the lamp off now, you have to go create another file with lamp off. So you're going to have lamp on and lamp off, okay? So that's basically all you have to do. These are the only 2 things you're going to have to change, okay? The only 2 things you're going to have to change. It's right here and right here. Okay, so that's it, guys. Remember, this is Python 3.4.4. So this is Python 3.4.4, and if you have Python like 2 or something, you're gonna probably get some syntax errors within here. So you're just gonna have to modify it to see it fit. Okay. Oh. So just so you guys can see, all of my scripts are like this on the Windows PC. See, this is the Palm Tree off. The only thing that's changed here is the message that's sent is now it's not house light on, it's Palm off. Okay, that's it. That's the only thing that changed, and the host is the same. Okay, guys, that's step 2. It's kind of long-winded, so let's go on to step 3. Step 3 is gonna be a lot more involved. So just buckle up your britches, all right? And guys, keep in mind, if you guys have a problem with this, because I know I'm not the best explainer, and I'm a mediocre programmer at best, but I can help you guys because I'm the one that created this. So if you guys are getting confused or whatever, just leave a comment in the description, or comment in the comment box, I guess, and I'll help you guys. I'm serious, I'll help you guys. And there will be links to a bunch of resources in the description, guys. Links to everything will be in the description. So I'm just trying not to get you guys confused, because this is a really cool project, and I wish I was better at explaining things. Okay, so on to step 3. Okay, guys, so now we're on to step number 3, and this is by far going to be the most involved step. So here is the script that I wrote to host the server. This may look like a lot, but it's actually just a lot because I had to replicate a lot of the things 3 times because I have 3 different appliances running. Okay, so this script, all it does is it's in a little loop right here, waiting and listening for a connection from the Windows PC. It's waiting for that string. It's just waiting and waiting and waiting, and whenever it receives a string, it executes a function, okay? And that's all it does, and it's really kind of simple, but there's a lot of things I've put into it in order to like prevent like bugs and actually get it to work, because it didn't want to work for the longest time. Okay, so right here, guys, this is just a remote desktop I have for my Raspberry Pi. You could do this with a Raspberry Pi connected through HDMI and with a keyboard, or just headless like I have it here. So it's just remote desktop using Type BNC. So it's just super simple, and this one's running Python 3.4.2. As long as it's Python 3, you should be fine. Links to get Python 3, I'll put it in the description. So this is running on a Raspberry Pi 3, guys. You could run it through Raspberry Pi 2 or 1. It'll work perfectly fine, I'm pretty sure. But Raspberry Pi 3 is kind of cool because you could get Wi-Fi capabilities if you want. I'm not using the Wi-Fi personally, but you can if you want. It's there. Okay, guys, so let me just go ahead and start explaining what some of this stuff does. I'm not going to go just down the line because there's quite a few things we have to cover. Okay, so here's all the imports we're gonna have. All right. Well, actually, first let me explain. Okay, so as with the client, I'm gonna have two things up for download, guys. I'm gonna have the Python. I'm gonna have the server, my server. Okay, so I'll put up my server as an example. Now I'm gonna put a template. This is the template. As you can see, it's heavily modified. It's not as long, and I'll go on explaining how you're gonna use this template later on. But first, I'm gonna explain how it works exactly. Okay. Okay, so here is my script. Up here is where we're going to import everything. Okay, so it's going to import the sockets module, RPi GPIO. In order to get the Raspberry Pi GPIO pins to work, you have to get this stuff. Import time, import subprocess. I'm not sure if I actually used a subprocess in here. I think it was just here from when I was trying something out. And then import threading, because threading is really, really important. So you're going to want to make sure you have threading. Okay. And then GPIO set warnings to false. The reason I do this is because I had a really kind of weird problem. You guys may not have it, and if you don't have it, just if you may or may not have it, okay. Just watch out for it. When I got my relay board, okay, I got my relay board in the mail. The default state for the relay board was closed. Okay, so the default state for the relay board was closed, which that means power's going to it, although power was not going to it. That was just the default state whenever it was powered. Even though the relay, like the specific relays were not being powered by a GPIO pin, just because the board itself had 5-volt power from the Raspberry Pi, it defaulted to on and close. Okay, so that's one of the problems I had, and it set off a whole bunch of warnings, so I just set GPIO warnings to false. Okay, it's a very simple program, so I mean, you're not going to have like, oh, your GPIO Raspberry Pi is on fire. No, that's not going to be happening. So just put set warnings to false. And GPIO set mode will basically decide what numbering scheme you're going to use for the GPIO pins. Okay, I don't use the what's it called, like, how do I explain it? Like linear 1, 2, 3, 4. Like you're gonna count 1, 2, 3, 4, 5 GPIO pins. I use them as the board, Raspberry Pi board calls them. So there's gonna be like a 4 here, a 17 there. Numbers are all over the place, but that's how the manufacturer numbers the GPIO pins. Is right here. Is BCM. Okay. So once you guys get your Raspberry Pi, you're gonna want to look online to see what the actual GPIO pins correspond to and what their numbering schemes are for the board itself. Okay. All right. So now here I have GPIO setup. This is going to set up your GPIO pin. GPIO pin board number 4, not number 4, board number 4. Okay. And set it to GPIO out to give an output. And this is specifically for the palm tree light. So I gave myself a little reminder. Palm tree light. This one's for Christmas lights. This one's for the TV. Okay. And then, remember, I said I had a problem with the relay board defaulting to on, right? Yeah. I had them all defaulting to on. But when I turn on the Raspberry Pi and I run this script, I don't want all my lights to be on. I want them to stay off, right? Like, so once I turn my Raspberry Pi on and I run the script, I don't want like all my lights to be like bing and turn on in my room. So I want them to stay off. So basically, this is reverse psychology. Okay, so by saying that my palm tree light is true, it's actually off because remember my relay is set up backwards. Okay. All right, so there's that. So I just set all these guys. It's off, and nothing happened so far. All right, now here are these guardian bools. I just called these guard bools because they could be true or false. And what these are going to basically do is if I say palm tree on, okay, then it's going to switch one of these variables to true. It's going to switch this palm guard to true. And then next time, if I say palm tree on again, right? If I say palm tree on again, after I've said it once already, it's going to check. It's going to say, oh, is the palm guard on or off? Okay. If it's true, I'm not going to let that command execute again. Okay, I'm not going to execute the function twice. Because if I execute the function twice, then I'm going to have to tell it to turn off twice. Okay? So this is just kind of like a little debugging variable, just to make sure that I can only tell something to be on once. Okay. So that I just put these. So just make sure, guys, whenever you're creating your own appliances for this, you could have a Palm guard or appliance guard or whatever. Just make sure you set it to none right here, so it has no state until you set it to a certain state. Okay. So we still haven't started the loop yet. This is just like the beginning of the script. Okay. So now here's all these functions. Okay, I'm gonna skip these functions first of all, and then we're gonna actually skip and go to down here. Okay, so this is the while loop. This is the heart right here. Oh, maybe I should open that up. All right, this right here where it says while, right here, this is going to be the heart of your script right here. While true, it's just gonna be constantly going. Okay, it's just constantly on. While true, S listen, it's going to be listening. It's listening for the string of information from the Windows PC. Because remember, we're on the Raspberry Pi right now. So it's listening. Okay. So now, it's listening for connections. You could see right here, listening for connections. This is where we're at right now. Actually, let me just restart this. Yes, I'm going to kill it. Let me restart this so we can get a fresh thing. Okay. Local socket created, socket by complete, listening for connections. Okay, so now we're right here in our while loop, listening for connections. Whenever we get a connection, we're going to accept it, and if the connection is this one, which is the static IP I've set for my Windows PC, is 192.168.1.1.1, whatever. It's gonna say that we're connected with it, and the name is Lizzie because that is the name. Lizzie, that's the name of my Windows PC. And if I get a connection from an address other than this IP, okay, then it'll say unidentified connection because that's obviously not someone I want connecting to my Raspberry Pi. Okay, and then data. Okay, data is big. This is the variable that is going to basically run all the functions you have within this script. So data is constantly changing, and data is the string that you sent over the network from your Windows PC. From the script that we ran on our Windows PC, that is converted into the variable data. Okay, so we receive the connection and we decode their ASCII text. Basically, and then we're going to print what the client says. So we print whatever message was sent to us, okay? And then we're going to send a reply. Now, obviously, we already saw in step 2 that I sent the reply. Okay, now we're going to dissect the data, okay? So now, we're going to say, sorry, there was a motorcycle. If the data, all right, so here's all of our if statements. If our data, once we receive it, turns out to be Palm on, or house light on, or TV on, okay, then we're basically going to run a function, all right? But if the data is, say we're doing house light, because that's kind of been our test case. Say if data is equal to house light on, so this is the string we sent over the network, and our house guard, all right, is not true, so it's false, basically. This is the one we were talking about earlier, the variable we were talking about earlier. Then it'll run the function house light on, okay? So we'll go up here to the function house light on. And this is where it got kind of tricky when I was creating this, guys, because I couldn't figure out a way to have to simultaneously have two things going on at once in Python. That's where threading comes in. Okay, so it's going to basically run house light on, this function house light on. Okay, excuse my language here, but remember this entire thing is messed up with inverses. So because my relay switch is came out of the factory like backwards, it's interesting. Okay, so basically this count thread is going to set up our thread. This is the thread itself, and then for I in range of 1, because we only want one thread for here. Threads are basically like a little they're like processes that happen outside of this script. They're processes that happen outside of this script. Okay, so it's basically going to run this thread, and T start means start the thread. And this thread specifically for these lights is a while loop, all right? So this while loop imports global data, all right? And it's going to import global house guard, okay? Because this is the house lights on. And then it's basically, as we're running through the while loop, for house lights on, it says if data equals house lights off. So if we ever send a data string, if we ever send a string from the Windows PC that says house lights off, and this while loop is running because the house lights are on, it'll basically turn them off. All right? Because if data is house lights off, then it'll set this GPIO output to true, which is actually false, remember? And then it'll set the house guard to false, so it'll basically reset the house guard to say basically the house lights are off. Basically
house lights turned off.
Oh, Risk was listening to me. And then right here it'll just print something right here in the little console. Just give us a confirmation, and then it'll break this while loop and break the thread, and then we're gonna go back down here to the this loop. Okay, so then it'll be like this thread never happened. Okay, but otherwise, once we say house lights on, it'll just go while true, and it'll print house lights on, and it'll set this GPIO, which is the GPIO pin specific for the house lights. It'll set to false, which is actually true, remember, and it'll close the circuit to turn the house lights on, and then it'll set time sleep 2. So this while loop repeats every 2 seconds. Okay. All right. So that's basically how it works. I skipped this part right here. Time variables. This is just C. This basically just puts a time right here in front of all of my little prints that I have here, just so I could keep track of like when was the last time I said this or whatever. So this is a little time variable. So if you ever see C, like right here is C, that's just time. All right, nice. Now I skipped this part just because this is where it's setting up the server socket, or the socket server. So the host is yourself, so you don't put anything on port 12344 and 12345. And then here's the TCP socket, and it'll print TCP local socket created. Okay, because it basically declared that the S variable is going to be the TCP socket. All right, now it'll try to bind the host and the port, which is to yourself, and if it can't, it'll give you an error. Okay, so then after that, it'll just go directly into the while loop. And that's basically it, guys. That may have been like the worst explanation I've ever given for anything. So let me just give you like a super quick rundown on how it works. All right, so here is the template I've made. The template's basically the exact same thing. Okay, so it's the exact same thing without all of my configurations. Okay, so without all of my GPIO settings and without all of my function settings and everything, it's just a basic template. All right, so right here, as you can see, I have GPIO setup number 4 for my palm tree light. Right here, all I've put is GPIO setup number and then an example. Okay, so the number, say you want GPIO, say number 7. So you put 7. Now you set up GPIO number 7. All right, so and then you're gonna set the output right here to 7, and that's one GPIO, that's one appliance. All right, you can see how it's set up right here. So it'll be GPIO 4 and then GPIO output 4. Okay, so here is the Guardian bools. Remember, we need these not for redundancy. We need these to make sure that we don't have to tell lights to turn off twice. Okay, so remember, we could tell our palm tree to turn on, and if without this we tell it to turn on again, it'll just turn on again and it'll run another thread. Well, we don't want it to not run another thread. Now it's running 2 threads, and then to get rid of those 2 threads, we have to tell the palm tree to turn off twice. We don't want that. We want to be able to tell the palm tree to turn on once and turn off twice, and then if we tell it to turn on after it's already on, it just won't do anything. So that's what these things do. Okay, I just put appliance. You can rename this to whatever you want, but just try and keep it like organized. So like right here, I have palm guard, and then down here I have the palm tree I have palm on function. Okay, so this is palm. This is all one thing. So then palm guard is here, palm guard, palm tree. Everything's like palm in this function. So you just try and keep everything organized. So right here, everything that says appliance, you could basically switch out for whatever you want. Just keep the same syntax so you don't have capitalizations everywhere. So appliance. Say you're going through and you want lamp. All right, you just go through lamp. And you'll go through, after you set up these GPIOs, of course. And then define, you'll go lamp. And down here, you do lamp. 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 You may not have to do it here on the string, but lamp. Lamp. And then whatever GPIO number you set up, you're going to stick it here and here for the lamp. And that's basically how you set up the if you were planning on setting up the function, that's how you set it up. And then the only other thing you have to change is down here, guys. Obviously, all right. Say we go through here, and you're also going to change it. Oh, I put an example here, guys, just so you guys have an example. All right, now say the other things you have to change in the template. You're also going to want to change this. Chill. Okay. Whoa, we're getting. All right, here's the name of the Windows PC. Remember, my PC's name is Lizzie. If your Windows PC is named like my computer or something like that, you're gonna just name it my computer. Okay. Okay. Here's the address of the Windows PC. So here you're going to want to have a static IP for the Windows PC. So remember, mine was, that's not actually the one I use. It's just the one for this testing purposes. But say you do that one, or 123 or whatever, 123 or 124 or whatever. Just whatever static IP your Windows PC uses, you're going to want to put it here. Okay? You're going to want to put it in that box. There you go. You're going to want it in a string too. Okay. So then after that, you're going to go down here and then if data. All right. So here is the string. You're going to want to make sure that this string is the exact same one that corresponds to the Python script on your Windows PC that you run with voice attacks. So if it was lamp on that you set up on your Python script in your Windows PC, you're going to want to put lamp on here. Okay, and then down here, appliance, basically switch out appliance for whatever thing you want. Lamp guard, and then the appliance on function is the lamp on function. And then down here, you want to put lamp. And down here, lamp. All right, now I put an example here too, so you can see how I did it. And that's it, guys. Then basically you just run this. You could set this up if you guys know how to get your Raspberry Pi to run scripts upon boot. You can get it to run on boot, so you don't even have to touch your Raspberry Pi at all. But I kind of like using my Raspberry Pi, so I don't have it to set to run on boot. And last time I did that, it kind of borked my Raspberry Pi and I had to reinstall. What's it called? The Debian, what's it called? Fork or whatever? Whatever they call it. Raspbian? Yeah, Raspbian. Okay. So that's basically how it works, guys. Let me give you guys some examples. So here we're gonna run that. All right, TCP local socket created. It's basically waiting. We have our voice attack here. House light on.
House lights on.
All right, here we go. Now it basically connected with Lizzie. It says it printed out what our client said. Our client sent a string called house light on. It set house lights on, and then it set the house guard set to true. Okay, so our house light is set to true, and then it's also listening for connections again. Okay, so we know that the while loop is now running still. The while loop is continuing to run right here, and it's listening for that next connection, which if we wanted to, we could say house lights off. And every 2 seconds, it's going to be printing out house lights on because it's the house lights are running in a while loop. Okay, house lights off.
House lights off.
See, and basically it connected with Lizzie again because it was listening. Okay, so the Raspberry Pi was listening. It connected with my Windows PC once the Python script on the Windows PC was sent by voice attack. and the server here prints out what the client said, and now it's listening again, and it set the house guard to false. The server set the house guard to false. Okay, we can also go right here. So, oh geez. We can also just run these Python scripts just from, we don't need to use voice attack to run them. We could just run them from the folder right here. So we could put Palm Tree on, and now Palm Tree is on. See? Palm Tree is now on.
On.
Oh wait, what'd I say? And then we could say like TV on and house light on.
Lights on.
Now all of our lights are going on. Okay, so every 2 seconds these lights are getting, their threads are getting reset because they're in a while loop. But now I could put house lights off and Palm Tree off and TV off. Oh, it didn't go through for the... There we go. And that's basically it, guys. So that's how the server works. And now I'm going to go on to step number 4. However, step number 4 has a caveat, but we'll get to it when we get to it. So, remember, guys, links for everything will be in the description. If you have any problems, let me know. There'll be links to everything. And I know this time is not correct, guys. It's like, I think this is GMT time, Greenwich Mean Time. Or it's some type of time format. I could not, for the life of me, get my Raspberry Pi to read my local time. So this is honestly just here for debugging purposes. If I ever wanted to add something onto here and I messed it up, the time is there for like debugging and just kind of like data categorization purposes. Plus, it's just kind of fun to do. So that's that, guys. On to step 4. Alright, guys. Well, we're back on my camera, and I'm just going to be going ahead and telling you guys how I set this up and basically what this is about. Okay, so remember how step 4 is the relay itself and the connection to the Raspberry Pi. Okay, so first and foremost, ladies and gentlemen, do not build a enclosure like I have built right here. I have wires, live wires going everywhere. Okay, first off, I have like bits and pieces everywhere. And if I were you guys, I'd build an enclosure that was safe and that people are not going to be sticking their fingers into, okay? The only reason I built this like this is because I was kind of half-assing it, and no one's really coming in here to touch it except for me, and I know not to touch it, okay? But if you were guys were building something like this, where children can get to it, or other people, or they'd be like, ooh, that looks cool, and they want to touch it, build it in a safe enclosure so no one gets electrocuted, alright? Okay. So, then we get to the Raspberry Pi. So, the Raspberry Pi itself, it connects to here. Guys, okay, first before we get to that, there's going to be a link to an Instructable that I followed that showed me how to wire this exactly how it needed to be wired, okay? Because the Instructable that I followed, the guy created a web UI controlled appliance. So, instead of voice controlled, it was a web UI using Apache web server on his smartphone. However, I didn't want to go through that hassle, and plus I think voice controls are a little bit cooler than Apache web server. So, I'm going to put a link in there, guys, because if you want to learn how to wire this, I'm not going to show you guys how to wire this. If you want to learn how to wire it, follow his tutorial, and it will teach you basically how to do all this. This is a really great tutorial, and just shout out to that guy because he showed me how to do it, and it came out really nice, other than the enclosure. Okay, but that's that, guys. Also, a little caveat here, I did not foresee me having to ever take it apart, because I'm never going to take this apart, because I know I'm not going to be able to put it back together because I used so many different types and unconventional types of wires, and I use like green wires for the ground and green wires for like the active wires, so if I try connecting it again, things are gonna start blowing up, alright? So if you guys want to do this, I suggest, if you don't plan on taking it apart, it doesn't matter what wires you get, okay? If you plan on taking it apart and stuff and like troubleshooting it and stuff, get the correct colors of wires. So like you're gonna want like green and red and yellow and black and whatever kind of wires you need that will correspond to like live and hot wires and ground and stuff like that. Okay, so that's my little PSA, guys, on this electrical stuff. And I got this, you guys don't, okay, so this relay board I got off of Amazon. It was pretty cheap. I don't remember exactly how much it was. I think it was like $15 maybe, something like that. But you could get them in like, you could get them in single relays, in like 4s and 8s and 16s. The Raspberry Pi, it could do quite a few, but I only did 8 because, I mean, I only have 3 plugged in right now. I can't really plug that many things into it. There's only so many things I could power in my room. So it was just basically a cool little project. Now, remember how I told you guys these things default to on. These appliances will default to closed. To close the switch once power gets to them. Even if it's not through the GPIO pins, once this board is powered, because this board needs 5-volt power from the Raspberry Pi, they default to off, okay? All right, guys, so as a little proof of concept, I'm going to go ahead and turn some of the lights on. Lights on.
All lights on.
And you guys just saw 2 of the relay switches, the one that corresponds to the house lights and to the palm tree turned on, and the switch is closed, and then that's that. And guys, remember the Raspberry Pi 3 is Wi-Fi, but I have it connected via Ethernet right there. So that's that. Okay, guys. So the reason I did this project is just to learn a little bit about everything. Okay, I was always curious about the Raspberry Pi and just kind of real life computing and just being able to interact with mechanical things outside of, you know, like a computer. So with the Raspberry Pi's GPIO pins, it makes it so much easier to do that. And this is a fun little project. So I was able to learn, I got to learn a lot of Python. So I actually know at least a little, obviously I'm not great at programming. You guys saw my explanations of the of some of the scripts that I wrote. However, I got to learn a little bit about Python, and it's certainly piqued my interest. So now I'm learning more and more about Python and programming and whatnot. And the Raspberry Pi gave me an outlet to do that. I got to learn a little bit of electrical engineering when I was wiring all these things using alternating current. Thankfully, I did not shock myself. However, I did learn, you know, about wiring and the Raspberry Pis and the relay switches and the switches themselves. So I did learn about that. I learned about navigating through Linux because I've never, well, I have used Ubuntu in the past, but I've never used what's it called, the Raspberry Pi's Debian fork of Linux. Raspbian. So that was pretty cool, and I got to use a lot of the, because Ubuntu is really like a watered down Linux experience because it's very, very much like Windows. So I got to use a lot of the command line interface with the Raspberry Pi. So that was really cool. So guys, all around this project was just really, really great. Just me learning about all this stuff, and it helps me just learn as a person. You just never stop learning. So that's that, guys. Here's where the you guys see all the GPIO pins back there. They're all connected. Each individual one is connected down here to the relay board. All right. Make sure you remember what those are, or else remember what the numbering sequences are when you're creating this. And guys, links to everything, absolutely everything that I used to create this project will be in the description. If you guys need help, just leave a comment and I will help you guys. And that's basically it, guys. So I want to thank you guys for watching. Thank you guys for watching a very, very long-winded video. Maybe not the best explanations out there, but I tried, and hopefully some of you guys will be able to get this. And hopefully I can help some of you guys, maybe pique your interest in getting a Raspberry Pi or working with all these electrical wires, because it was a ton of fun for me just learning all this stuff. So I definitely recommend anyone to try it. Especially if you guys have been wanting to learn Python, because honestly, like, I've always wanted to learn programming, and I've tried JavaScript, I've tried CSS and HTML, creating websites and stuff like that. It bored me out of my freaking mind. All right, and I couldn't get it. But Python, something clicked. It might have been the syntax, it might have been the way it's structured, it might have been the way that it works, and it's integrated with the Raspberry Pi in real life. It might have been a combination of all those things, but it's just so great. Because now I can create programs, and I can work with things like I am here. And Python's just really great for that, guys. It's a very, very powerful language. So if you guys were interested in learning something about that, there it is. So, okay, finally for the last time, thank you guys for watching, and I'll see you guys in the next one. I hope you guys enjoyed this unorthodox video. See you guys later. Bye.